Hello and welcome to this week's episode of Polymath Robotics, an incredibly new podcast when considered in geological timescale. This is our weekly podcast where we talk about robots.
I can't tell if you butchered the intro on purpose or like.
I asked Ilia if the microphone was new because it felt different. He said, on geologic timescales, yes, that mic is new. It is newer than the formation of the North American tectonic plate. Which made me feel really nice and smart. Anyway.
These are the boom arbs we've used since we started podcasting.
This is Automated, our weekly robotics podcast. I, of course, am Stefan Seltz-Axmacher. Sitting next to me is someone who desperately wanted me to read from his shirt for this podcast.
Oh, yeah.
And yet I didn't. I talked instead about geologic time frame, and you destroyed my app for what our game is.
You remember what it is?
Maybe.
Yeah.
I forget things.
We'll make it up as we go along.
With rapid frequency.
Different than our usual schedule.
Yeah. Well, he's not even going to pretend to introduce himself. So this is our podcast, Automated. First, we play a little game where we invent a robot by randomly pulling a technology or a market and having to cobble something together between the two. And then next, we talk about some sort of issue or topic or subject in robotics. Ilia, what are we talking about today?
So we are talking about why hardware is so expensive.
Yeah.
And it is not because Stefan needs a second Ferrari.
A third, ideally. I assume it's like a buy one, get two free.
For that, you have to graduate to the promised land of SaaS. For hardware, only one Ferrari.
I did hear about a founder of a well-known company who I'm not going to name who, after some level of traction, he got a private jet and stopped talking about his technical product and started frequently talking about his private jet with a lot of social media about his private jet.
Man.
This is a product the founder of a company that many of us have used products for, which is why I'm not naming him. That being said, our game today is we have to apply humanoids to search and rescue.
Oh, exciting.
Yeah.
Nice.
So what flavor of search and rescue should we be thinking through?
I mean, my mind immediately goes to collapsed buildings, but maybe that's too pedestrian.
Yeah. I mean, you could do, I just watched, mostly while I did some work, The Electric State, the movie.
Awful.
You know, the graphics were nice.
Even that's like questionable.
There was a construction robot that was humanoid-esque.
Which
a robot that worked with multiple different bodies, and the interface between these bodies was pulling levers inside one of the other bodies.
Awesome.
Yeah. I don't know if you actually watched the movie.
No.
But that was that's my favorite thing when robots don't have USB cables.
Oh yeah.
Let alone Ether.
The whole trope of
robot push
robot
buttons.
has to robot has to push buttons.
Yeah.
Okay, so search and rescue, you could do class building. You could do marine search and rescue.
Yep. You could do floating robots that come up.
What about forest search and rescue? That's the one I've been personally most involved in. Is somebody's lost in a forest, you have to go find them.
You've done that?
Yeah.
I've not done that. I don't want to find a dead body in the woods. I have no interest in making decisions. Give me a high likelihood of discovering a body in the woods.
Number one piece of equipment you need, extremely good hiking boots.
Yeah.
Everything else is secondary.
Yeah. I think let's do something less than a full collapse building, but a little bit more structural than a forest fire. Let's say there's a problem in a part of a building. So maybe you have to rappel down from the roof. Maybe you have to be hella dropped into the middle of a complex, like a Chernobyl type of situation.
Okay.
And then you have to go through uneven terrain, so having legs kind of might make sense.
Yeah, this is one of the few cases that you actually
and
legs
you have
benefit.
to pick up debris to clear your path.
Yeah, I mean, again,
and maybe you're carrying a stretcher or something.
I mean,
so you don't have to put the human over your shoulder.
Quadrupeds would actually be better at this.
No, but it's a humanoid.
Humanoid.
Yeah.
Humanoid that goes down on all fours.
Oh yeah, I like that trope.
But creepily, the Ring, where their arms go backwards and they start crab walking.
So thinking through it, going to our real main subject, we'll need really cheap humanoids. But let's just magic that into existence like most humanoid investors.
Right.
So you have a really cheap humanoid. It needs to have 4 hours of battery life. Actually, 6 if it's going to carry something back that weighs as much as it weighs.
Yeah, I mean, I think the first thing is it needs to be ludicrously strong,
Yeah.
which like most humanoids are not,
Yeah.
right?
Probably
Like,
needs to be able to move an I-beam.
well, I don't even demand superhuman strength.
Yeah.
I'm talking like human strength.
No, yeah, but like, I mean, like, I'm not
it
saying
needs to
like,
be able to deadlift, 200 pounds.
yeah, I'm not saying
Right,
like move an I-beam, like lift it up,
Yeah, yeah.
spin it around, and throw it
Yeah.
100 yards. I mean,
Yeah.
like an I-beam is leaning on a door,
Yeah.
like move it out of the way.
Yeah, shove it out of the way.
Yeah.
Yeah. Like it needs to be like strong human, average strong.
Yeah. But like firefighter strength.
Yeah,
So,
yeah.
so probably the ability to carry 300, 400 pounds
Right.
for 10 minutes.
Yeah, yeah.
Is probably a real spec.
Yeah.
And if the whole robot weighs 200 pounds,
Probably.
well, actually, I mean, I know with quadcopters, there's a thing where the bigger, for more flight time, you need more battery, which means less flight, more,
Yeah, it's
more
the
weight,
rocket
less flight
equation.
time.
It's the
So
rocket
is there a
equation.
rocket equation with humanoids with batteries that work similar?
Not as bad.
Okay,
It's-
because you can stand.
Because you can stand.
Yeah.
Right? Like it's not as good as wheeled machines where you literally use no power if you're standing still.
Yep.
But you're not using quite as much power
Okay.
if you're standing still.
But also you're using a lot of power for every step because you are lifting yourself a decent amount.
A little bit.
Yeah.
It more like if you're talking about the old like Asimo Honda style robots
Yeah.
where they'd like step balance on one leg, step balance on one leg, then you're using a lot more.
Yeah.
But a lot of modern humanoids will actually do like dynamic falling,
Okay.
which is closer to what humans do.
Okay.
And you almost have ball bearings at your hips, so you're kind of like you're
Okay.
stepping in a way that's fairly energy efficient.
Okay. Okay. So, I mean, you commented before that there's very little public information about the actual runtime
Runtime,
of the limited
yeah.
humanoids today.
Especially at this power usage.
Which I would say for probably a Atlas or a Optimus or whatever, little data means bad.
Yeah.
And I think bad means less than an hour.
Yeah. Yeah, I would be stoked to find a humanoid that has an actual real use case runtime of like 2 hours.
Yeah.
That would be fantastic.
Okay. So if we have 2 hours,
Yeah.
let's say we know exactly where the person is. When they got trapped in the debris, they had some sort of locator on.
Just high power irradiate the whole thing.
Yeah.
With like X-rays.
Yeah.
And find the person that way.
Yeah, so we
fine.
we can solve them. We can find. We know where they are. We have a blueprint of the building,
All right.
so we know exactly the path outside of damage.
Mm-hmm.
And like the damage does not change the floor plan. It just makes some doors hard to get through.
Okay. Yeah, like they're bent or something. Right?
Yeah, or like
Right.
you have to like get stuff by the door.
Yeah.
So maybe the helicopter drops us a 10-minute walk from where the person is.
Yeah.
So we have to walk.
Through some.
10 minutes with no destruction.
All right.
That could be 30 minutes with destruction.
Okay.
We have to pick up something that roughly weighs the same weight as us and carry it back.
And carry it out.
And my hunch is that probably eats an hour, hour and a half of our 2 hours of runtime, if that is a total of a 30-minute task.
Yeah.
Yeah.
Almost certainly. I mean, the thing is, this is one of those cases again where actual standard firefighting equipment could make sense. Like arm the thing with an axe
Yeah.
and just swing at whatever door gets in your
Yeah,
way,
or a shotgun.
or a crowbar. Shotgun, maybe not. But like crowbar and axe probably is a good first step.
Yep.
To get through most of your impediments, and a humanoid will probably could be made to be roughly as good as a human at swinging an axe. Crowbar, maybe not, but
Yeah.
axe, like mostly it's speed.
Yeah.
You don't need a ton of strength for that.
Yeah. So we show up. We walk up to the building. How do we think about doing a path plan? We have our ideal path, and then we have an ideal straight hallway.
Yeah.
There's a parallel hallway over here. The fastest path is this ideal straight hallway, and we're blocked.
I mean,
How do we make the decision? Do we move the debris through this door, or do we try the other path?
I think until like once you get there, you have a floor plan, but you have no idea how the structure shifted due to whatever earthquake, right? So you're basically back down to idealized path planning algorithms. So like A-star,
Yeah.
like run A-star. Whenever you get blocked, run A-star again. Figure out if there's any alternatives.
Well, no, but I mean, the decision is more than just run a path. It's how would we look at debris in front of a door and come to the decision that this is 2 minutes to remove, 30 seconds to remove, 25 minutes to remove, unremovable.
I think this is one of those like if I was running a humanoid company, I'd say we'll just collect a lot of data. we'll end-to-end model it, and the black box algorithm will spin out.
We'll go to 50 to 500 idealized destroyed buildings that have people trapped inside.
Yes. From one of our previous episodes, one of those guys will show up and, remember the firefighting robot that causes fires?
Yeah.
Show up, and for the people that don't pay the protection money, unfortunately, their building gets destroyed. And then the data collection robot shows up right afterwards.
Okay, so functionally, that looks like an open AI problem, like an actual AI problem of...
Yeah, how you guess what the structural load bearing is, I don't think there's any clear math
more
way
of
to
just
do it.
like, this is a lot of debris to remove, not a lot.
That's what I'm saying. I think that's probably well within the realm of deep learning.
Okay, so we've gotten to our person, and let's say we have a stretcher that we brought with us.
Yeah.
For like a 4-wheel drive stretcher or something. I don't know.
Right.
Or we could carry them back. Is this another like AI to make the decision for do we stretcher them back? Do we fireman carry them back?
I mean, I think
how do we decide what we actually like? What's best for the person?
I think the harder problem you're skipping here is like when you're actually trying to rescue someone who's pinned. It's figuring out, is it safer to try to treat them in place or to actually move them out of the way? That's the like.
Which starts to mean your search and rescue humanoid also needs to be capable of advanced first aid.
Yeah. Like if you look at actual earthquakes or bombings, for example, like finding the person takes, let's call it an hour, but then deciding how to get them out of that jam takes like 3 or 4 or 6 or 8 hours. Yeah. Because if a building is all structurally unsound, jackhammering them out of whatever corner they're stuck in, if they're not easy to withdraw, might bring down the building.
Yeah.
Right? Or might pin them worse. Or if their limbs are actually pinned, when you unpin them, when you unpin them, you might cause heart failure.
Yeah.
Right. So there's all sorts of medical concerns. So anyway, we're being told to wrap up. I'm just going to wrap up with...
How would connectivity work in a building like this?
Awfully.
Like,
really, really poorly.
Why?
Because most
there's
buildings...
no people there.
No, but most buildings, if you're using concrete, are rebar reinforced concrete. So and if it's now all collapsed around some object, you're now talking about basically a Faraday cage. So you have to have really loud radios. Or if you look at the real search and rescue robots, they'll usually actually set up breadcrumb systems where they'll have one robot drag a fiber optic cable and then a Wi-Fi for another robot, which then drags for the third robot.
Yeah.
And power, again, tethered power is probably pretty reasonable here.
Yeah.
Like that's actually probably a good solution for short distances.
Yeah.
Although then you get tangling and stuff. Anyway, my comment is this is a humanoid that's coming after a human with an axe. You have to call it, here's Johnny. That's the only option. Coming to a shining hotel near you.
And the price is whatever humanoid actually costs plus $200,000.
The price is whatever you'd pay to not get chased with a humanoid with an axe.
All right. Well, I guess why would it be so expensive?
Yeah, cost.
So, I mean, I saw a LinkedIn post, of which I showed 2 versions of to you, a widely disseminated series of LinkedIn posts that argue that a idealized humanoid would cost anywhere from $10,000 to $50,000. And they'll go through like bills of materials and be like, hand actuator, $1,500. Arm actuator, $1,000. Battery, $3,000.
So I think there's 3 directions to attack this problem from.
Yeah.
So the first one we got to call out is one of the most actually accessible humanoids you can buy right now is the Unitree one. And they do this trick where you can buy one for, let's call it $15K, and it essentially is a remote control toy. And then there's another version that they claim is the same thing, but that actually has sensing and compute and can do more interesting things. And that one immediately jumps to $80,000.
Yeah.
And again, I might be getting the numbers wrong, but that's the disparity between toy and thing you can actually use.
Or just like a mechanical device and the basis of a robot.
Yeah, exactly, and an actual robot.
The hardware basis.
And compute and sensing and all that stuff.
And part of why this is top of mind, so we just hired a great guy to help us with programs. He's a former founder, and he did this terrible thing that former founders always do, which is show up and immediately...
Question your ideas?
Question everything.
So specifically Stefan, though, just to be clear.
Well, I am beyond reproach. I've never said anything incorrect.
Right.
Ever. So he's gone and like, he's asked this, asked that, asked whatever, which is always is actually a lot of fun way to second guess all your assumptions.
No, yeah.
And
to be clear,
double
good
check
thing.
how reality works, especially since reality changes over time. And one of the things was like, hey, why don't we like find a way to do a really, really cheap deal for like Y Combinator companies where they could buy a robot relatively for not a lot of money, start developing on top of us, and like it'd be a land and expand sort of thing.
Yeah, and I called back to a previous episode where you were asking how do you automate a Nerf,
Yep.
little Nerf robot,
Yep.
right? And like
Which was this little toy that's $200 for us to automate it probably looks like $30,000.
yeah, I mean, well, even if we economies of scaled it, would still be like $2,000.
Yeah. and some of the question became like, oh yeah, well maybe one of our hardware partners says they could hand out a retrofit UTV with all the sensing on it, and like maybe for high five figures, and then we'd have to put our stuff on it.
Yeah.
Oh, that's a lot. Do you think we could get it down? And like, no. Like the vehicle is 25,000. The sensing and compute's 25,000, and it's probably 40 to 100 man hours in their shop.
Yeah.
So like you're just cutting margin.
Yeah.
Then the follow up question was, well, what about an indoor robot? Is there anything we could do there? And I recalled my understanding of the price of one of the lab indoor robots that we know very familiarly was $40,000 or so.
And there's like a healthy amount of margin there.
Yeah.
But like, it's still, even raw material cost, excluding any development effort, is still probably like $15K.
Yeah. And I mean, I think there's a general baseline of when you sell hardware, you charge 3 to 5x the bill of materials for the hardware.
Yeah.
So if it's $15,000 of stuff, a $45,000 price is actually like kind of on the low end.
It's very reasonable. Yeah.
And I guess the question is like, why is it all so expensive?
Yeah.
Because like the company that built that particular robot stopped selling them because it wasn't worth it.
Yeah.
So why do robot parts cost so much?
I mean, coming back to like the humanoid end of things, right?
Mm-hmm.
Like you can attack this problem from two ends. Mm-hmm. One is, can you build a humanoid looking machine for $20K?
Yeah.
Yes. Like Unitree exists. Yes, you can.
Mm-hmm.
Is that going to provide you human level performance? Clearly not.
Yeah.
Right?
Yeah.
That today, just even the most basic things like dexterity of hands,
Yeah.
or perception intelligence, or sensing quality, or battery life, or any of it, right? So that's one end is like, when you what is your goalpost for like human equivalent work?
Yep.
And then the other end of the goalpost is like, how many do you actually think you're going to build?
Yeah.
And we've seen some pretty crazy numbers, like we're going to build like 10 million humanoids.
Yep.
Like, great. You will suddenly be larger than Toyota next year. Like, good luck.
But like moving outside of humanoids,
Right.
I mean, like let's say we wanted to build a small indoor robot.
Yeah.
Something like the one that we have in the office.
Yeah. So that comes back to it, right? Like, if you're building at any kind of reasonable scale, if you want to do things like make sure that your motors are working reasonably well, your best actual bet is to go to the hobby market.
Yeah.
Cheap-wise.
Yep.
Because you can get really, really good brushless motors from, or the e-mobility market. You can get really good brushless motors from
scooter
China,
companies.
from
Yeah.
scooters, from electric bikes, depending how big of a robot you're making.
Yep.
Right? From drones.
Yep.
But those are only that cost because there's millions of them.
Yeah.
Right? And like before that appeared, if you were using industrial motors for your robot, I'm talking like late 90s, early aughts, they were very expensive because there was only 5,000 made a year, maybe, right? So you can start to lose some cost there. Again, if you can depend on commodity hardware, like you don't custom develop a computing PCB that just perfectly fits, but you just like stick a miniature
Your box
ITX.
can look ugly.
Yeah, exactly.
Yeah.
You stick a consumer grade, maybe slightly better than consumer grade mini ITX motherboard on there.
Yep.
Put a consumer grade GPU for deep learning if you want to do that. Like off you go.
Yep.
Right. But even on that end, right? So if you're talking about a decent compute, like how much does it cost to build a decent gaming computer? Relatively high end one.
Yeah, $4,000, $5,000.
That's very high end.
Okay.
Like that's the highest end. But like $2,000 for something that is extremely commodity but very, very powerful.
Yep.
Like that is a starting point for a robot.
Yeah.
Right? Like that is a table stakes in terms of compute power.
And that doesn't come with
GPU.
with a lot of ruggedness.
No.
So
it comes
like
with none.
I think there's a spiral that starts where it quickly looks like you're spending $2,000 to $5,000 on motors, even for a relatively small thing. A comparable amount of money on battery.
Yeah.
$2,000 on compute. Even relatively cheap sensing, $1,000 to $5,000 on sensing. You have a $15,000 bill of materials right there.
Yeah.
And then if you're going to sell something for $15,000, people want it to be really good. Or if you're going to triple your BOM for your price, $45,000, people want things that are $45,000 to work really well.
To not break immediately.
Yeah, which means you need better computers.
Yeah.
It means actually like that Alienware laptop that might fall apart if it's exposed to really, really hot temperatures or really, really cold temperatures.
Or just vibration. Honestly, the thing that kills a lot of computers is that they're not rated for the fact that if you're making a robot, I don't know what to call it, like smaller than golf cart but bigger than laptop.
Yep.
It vibrates the bejesus out of it anytime you drive around. Like
why is it so hard to ruggedize a computer? Like it feels like just put it in a shock-persistent box.
No, because it's not like impact that I'm worried about.
Okay.
It's the literal vibration. So when you vibrate a component very heavily, all the little pins start to get bent. Right? And so if you're using a USB cable, like our main enemy for years now has been USB cables. Because the USB spec, even USB-C, USB-A, doesn't matter, they're not built for high vibration.
Yeah.
So as you vibrate the thing, it starts to flex and come out of the connector.
Yeah.
So like you put it together and it works great, and then you run it continuously for 5 or 10 or 200 hours.
And it mystically just stops working.
And it just stops working, right? You start getting drop packets because your connector is literally vibrating out of the port.
Yeah.
And like, sure, you can glue it in, but then the little metal contacts start to fatigue.
Which is actually a fairly common approach.
Very common approach.
Yeah.
But like you've now delayed the problem, but it's not actually vibration rated. So eventually the contacts fail.
Yeah.
And it's the same for temperature. It's the same for impact. But these little devices, we don't really imagine it. But when you're driving even relative speed over the threshold of a doorway, like you've just dropped your 40, 50-pound machine by an inch suddenly, right? And you do that 30 times a day. Like there's no cell phone that survives that. Right? Like there's no consumer hardware. There's no MacBook that survives being dropped an inch 40 times a day for 3 years straight. Like it's just not going to do it. Right? Like so that's the problem with robots. And so you end up having to ruggedize everything, which means you get pushed into lower volume, more bespoke,
and
more
then there's a big
stuff.
order of magnitude expansion.
Immediately, it gets much more expensive.
Yeah, because like the connectors we often use, screw into what they're connecting to, which is not something that you can buy at Best Buy.
No, and even Ethernet is a step up.
Yeah.
And I'm a big fan of using Ethernet everywhere because it's already built for some of this vibration tolerance.
Yep.
But yeah, like we're switching to as often as we can kind of weatherized M12 screw-in connectors for Ethernet because they're just that bit more vibration resistant.
But there's a big drop in parts availability, which means there's probably an order of magnitude increase in cost just from those connectors.
That's right.
I mean, I think I've seen gigabit switches on bill of materials that we propose that are $1,000 for a switch.
Oh, easily, or $1,500.
And it's just a normal switch, but with M12 connectors.
Yep. Yeah, and temperature rated and vibration rated.
Yeah.
I mean, so the other direction you go here.
And what's frustrating to the listener, we have had a lot of programs suddenly stop working because of a bad switch.
Or a bad USB port.
Yeah.
Constantly, right?
Yeah.
And the other direction you can go here, though, is you go for massive scale. So this is the iRobot, right?
Yep.
Which, unfortunately, is not doing very well right now. We're seeing a lot of... Anyway, different question. But, like... If you custom engineer, and iRobot had a lot of really great, I think Bolt did a really good teardown series on the engineering of the iRobot vacuum cleaners. And like, if you custom engineer every single component and you stress test the bejesus out of it, you can get very high reliability at a very low cost.
Yeah.
What you pay for that is flexibility.
And CapEx.
Yeah. Massive CapEx.
Yeah.
And like whatever you've designed for this particular vacuum cleaner has no relevance for any other vacuum cleaner, much less any other robot.
And what's interesting is you see two things happen to startups who follow that. A, the lock-in means if they're not right about what their product has to achieve, they're hosed.
Yeah.
And the CapEx means they have to raise a whole bunch of money or they're hosed.
Right.
So, and to raise a whole bunch of money, they need to be more hypey.
Yeah.
Which means they're hosed if they're not very cool. And if they are very cool, then they have to make a bunch of commitments that mean that in the near future, they'll be hosed.
Yeah.
So almost in a way, needing to go down this path of high volume, low cost robots kind of just means you're hosed.
Yeah, you're in real trouble. You know, I would almost propose a triangle, like a engineering triangle of like low capex, low BOM cost, or flexibility, and like you can pick maybe one of those, and the other two are going to be awful.
Yeah.
And you know, here we try to target flexibility above all else, right? Because we want to work across a bunch of different vehicles.
Which typically means we have to work with larger companies, we have to charge more money, we have to,
Which means,
like the bill of materials on the robots that run tends to be higher unless they're spending a lot of money on CapEx.
Exactly, and making it super robust and super special purpose.
Yep.
But yeah, I think that's the inevitable trade-off of hardware is especially mobile robot hardware, not just a server.
Yeah.
Right. And I think even the server market and for example, GPUs and deep learning stuff has much larger economies of scale than robotics, and they still have similar problems, and their stuff doesn't even move around.
Yep.
Right. And so robots is even harder and even lower volume.
Yeah. It's a server with harder environmental specs and less dollars attached to it.
Yeah.
And I think also the problem is like as long as robots continue to kind of suck at their ability to do their core task, there's more low cost pressure. Because like if you can wash 50% of dishes, I'm not willing to pay you 50% of what I pay a dishwasher, and I don't pay a dishwasher very much.
Yeah.
So like I might be willing, if you're supplementing my human dishwashers and only doing the stuff that's easy for them to do, or easy for you to do, which is almost always also going to be easy for them to do, then in fact, like you have to cost a fraction of what I would pay a dishwasher on a year, which means you have to pour a whole bunch of money into getting relatively low cost at magic dishwashing robot arm project.
Yeah, and I'd say, you know, as a final thing, the other approach that I've seen here, and our infrastructure engineer called it kind of the Google approach, right, is if you look at Google prosumer/consumer hardware, what they did is they went for cheap hardware that breaks a lot, but with really good software that fixes, like just hides all of that from you as much as possible.
Huh.
And that's
I didn't know that was and also they're fairly willing to just send you a replacement.
exactly because it's cheap garbage hardware.
And a big part of how they're making their money is software derived.
That's
in their case, data.
And that's right. And what they've done is they've shifted hardware capex to software developer time, which they're good at,
and is way more scalable.
Which is more scalable in what they're playing for, right? So like, if you really want to play in the robotic space, and again, this is what we try to do, is shift as much of that effort to intelligent software that can detect when something's failed and
make up for it.
You change our behavior or call in a service or whatever.
Yep.
But that takes time. That's complexity. That's effort. That's not scoped in. And a lot of times, if you're a robotics startup or a robotics effort inside a big company, it's like, just get the thing to do a demo or work, and we can worry about reliability later.
Yep.
And like climbing that hill towards 90% reliability is a lot of like build a lot of edge cases to just hardware failure modes.
Yeah. Yeah. And that's not normally what those organizations have a stomach for.
Yeah.
They kind of need a thing that just solves a problem for them today.
Yeah. Yeah. And in addition to the physicality, if the robot stops doing what it's doing, you now have a dead object in the middle of the room. Rather than like if an app crashes on your whatever, okay, you just restart it. Yeah. Right? But like physical robot not moving.
A problem with atoms as opposed to bits is atoms get in the way.
Yeah, they just stay there. Best case scenario, they stay there. Worst case scenario, they continue off the cliff.
I think a new product line is we sell people a small reactor. Where if the robot has a critical failure and is in the wrong spot, it just melts down and causes the entire robot to melt into the ground so that it's no longer in the way.
Is this like the Chernobyl solution?
Yeah, I mean, it would solve itself. You wouldn't have to worry about driving into the thing if you made it hot enough.
I think the CIA wants to know your location.
So weird.
Yeah, I know. On that note, I hear knocking at the door.
Yeah. Well, I think that's it for today. We have a couple of really cool guests coming inbound. This will probably publish weeks after the fact, but on April 1st of 2025, we announced a massive strategic deal that will change the game in doubly landlocked country maritime defense. So I highly recommend you look it up. And Ilia, what are we going to talk about next week?
Well, considering we missed a few of these in a row, probably nothing. But the week after that, coming back.
I've got David from Carnegie coming next week.
Oh, never mind. There you go. David, thank you, producer.
That's actually next week?
Yeah.
No,
So there you go.
We can
2
edit
weeks
this
in
out
a
a
row.
little bit. So next week, we actually already have a podcast locked in. David LaRose from Carnegie Robotics is going to join us. And I'm going to ask him how annoying it was to do robots way, way, way long ago in the before times of Ross.
That's right.
And probably some number of other questions. Or just that question over and over and over again.
How did you build robots with punch cards?
We'll see you guys next week.
See you next time.